Hi there and welcome to this video on drawing ray diagrams in the Senior Physics Light and Waves series. Okay, so in this video what we're going to do is basically try and understand how to draw a situation that we've got with light when they're hitting a variety of different types of mirrors. We're going to be looking at plane mirrors and curved mirrors. So let's start off with a plane mirror. Now, when I get my students to draw the situation that they see with a plane mirror, I always start off by saying, draw in your mirror. Now, your mirror is always just a flat surface, and then it's got hatched lines to show it's solid behind that surface so that light can't get through. So we've got our plane mirror drawn down on the screen, as you can see there. Now to that, we're going to add our normal. Now remember, our normal is always at 90 degrees to the boundary surface. Okay, now that's always drawn as a hatched line. It's an imaginary line and it can exist anywhere along that mirror surface. But basically we use that so that we can do our measurements as to where we're going to be putting the angles for our rays. So the next thing we're going to put on is our incident ray. So this is the situation that we experience. The incident ray is coming in and that is placed at an angle to the normal. Keyword there being to the normal. Now obviously because we've got a mirror, it's going to be reflected off so that when that incident ray comes in, the reflected ray is going to bounce off in the opposite direction. And the key thing to understand that the angle to the normal of the incident ray is exactly the same as the angle to the normal of the reflected ray. So the two are the same. And it's always important that you write down what the angle is, what you find, so that you put all the information onto the diagram. The key thing to understand with the plane mirror, as I stated earlier, is that the incident ray angle to the normal is always the same as the reflected ray to the normal. Make sure that you do not do it to the angle to the mirror, so from the mirror to the incident ray or from the mirror to the reflected ray. It's very, very important. The angle is always from the ray to the normal. Okay, so plane mirrors are fairly straightforward to deal with, and you may have to put a variety of different incident rays and reflected rays onto that diagram so that you can interpret it and show your situation. So what happens when we deal with a curved surface? So when we're dealing with a curved surface, I always like to draw a template which starts off with a horizontal straight line which we call the principal axis. This is what the object's going to be placed on. Then I draw a vertical line which is going to be up my mirror. Now I'm not going to be putting any hatches in there and I'm not going to be putting any curves in there. The law will allow me to demonstrate the use of either a concave or a convex mirror just by following through the steps that we're going to go through in the next slide. So we draw our mirror in and then we have to place in our center of curvature. Now the center of curvature basically is the point at which if I was to continue the arc of the mirror, that would be the point where I put the compass point. So as I move around to draw the arc of that circle, that would be the center of curvature. The mirror would be here, center of curvature here, and of course the concave or convex mirror basically is just a portion of that large circle. Okay, so I'm going to put C as my center of curvature and I put a point on. So in your question you may be given that center of curvature and that will be important and you'll see that later on. Now the next point that we need to put on our template is our focal point. Now our focal point can be deduced from half the center of curvature. That is where the lines are actually going to cross. Okay, that is the point where we will get an image which will form. So the focal point we put on as a little f and is always half the center of curvature. Okay, so you can see it's halfway up to the mirror. So I've placed my focal point on. That might be given to you, or another way in the question is to give you the center of curvature and expect you to understand that the focal point is always half the center of curvature, so you have to put that on. The focal point is the important point that you need because one of the laws requires you to pass through that focal point. Okay, then I draw my object. Now my object, don't draw the object which is being described in your question, just use an arrow. That will be maybe a specific height and it will also be a certain distance from the mirror. If you're really unlucky, they'll say from the focal point or from the center of curvature. So use the information in the question to deduce where you're going to put your object. Your object is placing upwards, okay, and then we will use that object then obviously to do our calculation, our drawing. And finally, we're going to draw our image. Now, when I draw an image, I always draw it as a hatched arrow, okay, so I can deduce the difference between an object and my image, and the image is always formed where the two rays are going to cross, and we'll talk about that again when we run through our scenario. So that's the template, that's how I will set it up. Principal axis, mirror, you need center of curvature or focal point, and then place the object. Your image will be decided upon when you draw your diagram using the laws. So let's look at the first curved mirror, and we're going to look at a concave mirror. Now, a concave mirror basically causes our image or our rays to converge. Okay, when it converges, they bend in on each other and they cross. So basically what we need to do is we work out our focal point either from the center of curvature or from the question. We place our object on the template, a certain distance away from the mirror, and then we have to follow the two concave mirror laws. Now, the two concave mirror laws, as you can see in the diagram, are going to be shown as follows. The first law is looking at the red lines. So you can see the object there, the black arrow, and the first line goes parallel with the principal axis. It hits the mirror and then comes back through the focal point. So you draw parallel with the principal axis, then it hits the mirror, and then from that point you then line it up with the focal point and draw a straight line. So that's the first one. The second law basically follows the blue line, and in this case the top of the object goes through the focal point to where it hits the mirror, and then it goes parallel with the principal axis. So from the top of the object through the focal point to the mirror, and from that mirror horizontal parallel with the principal axis, and where the two lines cross is going to be our image. Now you can see in this case the image is upside down, and in this case it's slightly enlarged. Okay, we also call it real. Now, why is it real? Well, basically the lines converge on the same side of the mirror. Now, for a concave mirror, it's going to be shaped this way. Okay, so the mirror will be pointing outwards, and the rays are converging inwards. So if I was to get a sheet of paper and put it where the image is, I would actually get a reflected image straight on that piece of paper. Hence, it's real. So what happens with a convex mirror? Now, a convex mirror is basically one that causes the rays to diverge, i.e. they get further apart. Now, the result of this is always going to produce a virtual image, because the image is going to be formed on the back of the mirror, so it doesn't exist, hence it's virtual. Okay, so they diverge. So we do the same sort of thing as we did for concave mirrors. We put our principal axis, our mirror, our focal point, and we put in our object. Now, remembering that what happens with a convex mirror, the shiny surface, the reflected surface is here, okay, and the rays will go outwards. So the curvature is on the opposite side. We'll have our object on this side, but our curvature and focal point will be on the opposite side of the mirror to where the object will be. So remember, mirrored surface here, object here, and because we've got a curve here, our center of curvature exists on the far side. Okay, now when we draw our diagram, you can see I've got C dash and F dash. That just gives me an indication as to what I would call the far focal point and the far center of curvature. But it's the F and C on the right hand side which I am particularly interested in. And I follow the laws as normal. So let's start off with law 1. We go horizontal with the principal axis, and then basically I draw a line from the focal point, okay, noticing it's on the right hand side, and then I pass it back up from the mirror. Now remember that the rays are going to diverge and go outwards. I then do the same with my blue line, my second law. I pass from the top of my arrow through the focal point. When it hits the mirror or the vertical line, I then pass it back parallel to the principal axis. Now you've got to remember that the shiny surface is here, so it's reflected in these directions. Now, because we've got one light ray going this way and one light ray going that way, they're not going to converge. They're not going to come together. They only converge on the right-hand side. And you can see when I track back with my hatch lines, where the 2 points cross is where the image is going to form. And the result of that is that I get a diminished image. It's small, okay, it's the right way up, but it's on the opposite side of the shiny surface of the mirror, hence it's got to be virtual. I can't put a screen behind the mirror and the image be reflected on it. It's not going to happen. It's a trick of the mind's eye. Okay, so I hope you found that useful. So what I'd like you to do is check out some of the example videos that I've done for you, and hopefully that will make more sense because I work through the problem with you so that you can practice. So thanks for watching, and join me again.